Lesson for our first unit on functions. So we're talking about inverse functions, talking about what they are, how to find them, how to look at them algebraically, graphically, lots of different things. And keep in mind, hopefully you'll be very confident because you have worked on these in other classes before. So this first example is just giving you an idea of kind of what it means to have something that is an inverse function. The most basic kind of definition or instance I can give you would be probably something you did in 7th grade or 8th grade, where your teacher would have shown you a list of ordered pairs, right, x and y's, and then if you take all those x and y's and actually switch places, all right, so the x's become the y's become the x's, and graph those points would be the inverse points for the original ones. So that idea is kind of hold true for all of our conversations today on inverse functions. The notation I want you to think about is this f to the negative first power of x. All right, we actually just say that is f inverse of x, or the inverse function of f of x. Key thing here is it's not going to be something you put in the denominator. All right, so ultimately we're talking about using that notation. Something you did in Algebra 2 were to be taking your understanding of composition of functions and seeing if two functions were inverses of each other. And this all hinges on the idea that inverse functions are reflective over the line y equals x. And I'll show you, especially near the end of this lesson, using Desmos, using a graphing calculator, how that holds true visually for you. And that's always because you're changing the x, you're switching the x and y's when you're finding the inverse. So this idea that they're reflective over that line, y equals x, means that if you were to compose two functions and you get x for both of them, then these two functions are inverses of each other. So I'll give you an example. So let's try f of g of x. So using composition that we talked about a couple lessons ago. So I take the outside function, so 1 over box plus 2. I'm going to plug in 1 over x minus 2 inside the box. All right, so I'm going to get minus 2 plus 2 makes 0. So I have 1 over x, and 1 over anything is just that anything or x. Now let's do g of f of x. All right, so take the g of x function, so 1 over box, and then minus 2 out here. Plug in here 1 over x plus 2. As I said before, 1 over anything is just the anything, and then that becomes just x. So the idea here is that since both of these were equal to x after I compose them, the f of x and g of x functions are inverses of each other. All right, let's try the next one. Let's do the same process. We have f of g of x, which is going to be box cubed minus 4. Plug in your g of x function, which is the cube root of x plus 4. Cubing a cube root, those are inverse operations, so that's going to go away and just leave me with x plus 4 minus 4, which does give me just x. Do the other way, g of f of x, and do the cube root of box plus 4, and plug in x cubed minus 4. That's going to make 0 inside there, so I have the cube root of x cubed, and as I've already said, the cube root and the cube, those two functions are inverses of each other, so that gives you just x. All right, so again, because both of those are x, f of x and g of x are inverses of each other. All right, now remember, both of them have to be equal to x for this to be true. So as I move to the next example, something that a lot of students kind of realized when I taught this many years ago in Algebra 2, is that if you do the first one and you don't get x, you don't need to do the second one. Because both of them have to be x, once you get the first one as not x, you can be done, and they are not inverses of each other. So let's try f of g of x. All right, so do the first one, which is box cubed. When that's 1/3 x goes into the parentheses. And when you do that, you get 1/3 cubed, which is 1 cubed over 3 cubed, which is 27, times x cubed, which is definitely not just x. So this would tell me that f of x and g of x are not inverses of each other. Now, let me be clear here. Just because these two functions are not inverses of each other doesn't mean they don't have inverses. I could take the time to figure out what each function, their inverse actually is. So just because they're not necessarily inverses of each other doesn't mean they don't have an inverse. Let's try this one. So f of g of x is going to be box inside these parentheses minus 1 cubed. Plug in the cube root of x plus 1 in the box. All right, that's going to be plus 1 minus 1 makes 0. So I have the cube root of x still in parentheses, all of that cubed. All right, and cubing a cube root is going to be just x. So that one's good so far. Let's keep going. G of f of x. So do the cube root of box plus 1. And inside the box, we'll put x minus 1 cubed. Again, cubing a cube root here. I guess I should say cube rooting a cube. Our inverse operations, so it leaves me with just x minus 1 and then plus 1, which also equals x. So another example where f of x and g of x are inverses of each other. All right, let's keep going. Now, one thing that you'll see, especially as you get to the latter part of this lesson, is that if you're talking about two functions being inverses of each other, that means not only were their x's and y values switched, but also the domain of your original or your f of x function and the range of that function are going to trade places with your inverse. Okay, so the domain of your original becomes the range of your inverse, and the range of your original becomes the domain of your inverse. All right, we'll talk a little bit later about some restrictions that might have to be placed on here, but ultimately that's kind of the gist of what this diagram is talking about. Okay, so let's look at finding some examples here for the domain and range, or just inputs and outputs of functions and their inverses. So it says for f of x, so for f of x, the domain is 1 to infinity, and the range is negative infinity to negative 2. So now we're trying to find the domain and range of the inverse function. So f is the negative first power of x. All right, so that domain should be the range from the original. So negative infinity to negative 2, and the range will be the domain from the original, which is 1 to infinity. So they literally just switch places. All right, so we have a one-to-one function, all right, which means that when you look at this, it is going to have no repeats in the x or the y's, so that's good here. What are the corresponding input and output values for the inverse function? Well, what I like to do here is for f of x, write down these ordered pairs. So when I plug in 2 in the x value, I get 4. When I plug in 5 to the x value, I get 10 in the y. So for the inverse, all that means is they're going to trade spots. So when I plug in 4 into the inverse function, I get 2. When I plug in 12, I get 5. So this idea of changing the x and y's is going to help you a lot near the end of this lesson. Let's try one with a table. So this says we want to find and interpret f to the negative first power of 70. So let's just find, what I like to do here is I'm going to switch the x and y's, and I'll use red here. So if I switch the x and y's, I get 20 and 30 and 40 and 50, 60 and 70 and 70 and 90. So for finding the inverse of 70, what you want to do is find, when I switch them, which one has 70 now in my x position, if you will. In this case, it's over here. So we have f to the negative first power of 70 is 90. So just to interpret it by words, not that concerned about this, but it says F of t shows the distance in miles that a car has traveled in t minutes. So if we flip that, it's going to be the amount of minutes a car travels given a certain number of miles. So this would say, given that the car traveled 70 miles, we're expecting the amount of minutes that took to be 90 minutes. All right, let's look at a graph. I think this can be a little tricky when you're doing this, but hopefully going back to a few examples before where we looked at where your x's and your y's switch places, ultimately I think that's going to help. So like, for example, in A, where it's asking us to find g to the negative first power of -1, ultimately my first thought is if this number is my x in my inverse, then it's actually 1 is the y value for my g of x function. All right, so what I do is I try to find, okay, where is the y value 1? All right, so when I look on this function, I look to see the y value is 1 at 3, 1. All right, so at 3, 1, that's going to help me figure out the inverse, right? So when I flip them, so g to the negative first power of 1, or the inverse function, evaluate at 1 is going to be 3. They switch spots. So that's kind of the way that I kind of focus on this. Let's try B using that same strategy. So in this case, if I'm going g to the negative first power of 4, I'm looking to see that 4 is the y value for g of x. Okay, so I go to my function. My 4 is way up here, right? If I take my estimation here, I'm going to estimate it right around 5.5. All right, so that means I have 5.5, 4. And because I'm looking for the inverse evaluated at 4, I know that that should approximately be 5.5. So that's kind of the process that I think is the simplest way to do this. Okay, so finding inverse algebraically. You guys have done this a ton in your algebra class, and it's really 4 steps. First step is to change your f of x to be y. Second step is to switch x and y. Third step, solve for your new y. And the fourth step is to ask yourself, is my new function, is what I wrote, my inverse, still a function, or do I have to say it's a relation? All right, so first step, step number 1, is to replace f of x with y. All right, step 2 is to switch x and y. Notice nothing else changes, guys. Only thing that changes are the x and y. So step 3 will usually take more than one step, where step 3 you're solving for the new y. So I'm going to move that 4 over. I get x minus 4 equals 2 over y minus 3. I'm going to put that over 1. All right, and I'm going to take this as a proportion and cross multiply. So get y minus 3 times x minus 4 equals 2 times 1, which is 2. Move the x minus 4 over because I'm solving for y to get 2 over x minus 4. And the last step is to move that minus 3 over to write plus 3. All right. Now, I knew from the very beginning that this original function is a rational function. All right. So when I do the inverse, I also got a rational function. It's still a function. So I'm going to actually rewrite this. This is step number 4, right? So step number 4, where I rewrite this as f to the negative first power of x, or the inverse function of f, is going to be 2 over x minus 4 plus 3. All right, now I'm going to show you, something that you probably don't need to graph to do this, but I want to kind of visually show you what just happened that we did all this algebra. So I'm going to graph the original 2 over x minus 3 plus 4. So I'm going to graph 2 over x minus 3 plus 4. Okay, so 2 over x minus 3 plus 4. All right, so that's the original. There we go. Now I'm going to graph my inverse, which is 2 over x minus 4 plus 3. 2 over x minus 4 plus 3. And you might be thinking, wow, they look very similar. But if I put this y equals x here, all right, and think of it as not a part of the actual graph, so I'll make it a dotted line. If you look, I know it's kind of hard to tell because they're very close, but the red and the blues are they are flipped across this y equals x line. So they are reflections across that line. So let's see if I can get some ordered pairs here. Let's see, probably right here, 4, 6. So if 4, 6 is on my red one, then when I flip that ordered pair, I should expect to see 6, comma 4 on my blue one. So let's go to 6, comma 4. There it is, 6, comma 4 on my blue one. So that's kind of the basic idea that I want you to think about for this. Now, in terms of domain, because this blue one, which is my, let me take the other ones away, because that's my inverse. My domain, you'll notice, is any number I want, except we can't use x equals 4. So like I've done in the past, this would be what we call a vertical asymptote. So I am going to write this. I'm not sure if I would really take off points for this because it's not really what you're being assessed on. But when I do write my answer, I like to be thorough. So I'm saying, okay, use any point you want, but don't plug in 4. X cannot be 4. Okay, let's try another one. This square root function. So first step is to write y equals 2 plus the square root of x minus 4. Second step is to switch x and y. So x equals 2 plus the square root of y minus 4. Step 3, which will take a little bit, is to solve for the new y. So I'm going to move that 2 over to get x minus 2 equals the square root of y minus 4. To get rid of a square root, you guys know we're going to square both sides. As I mentioned in a previous lesson in this unit, do not expand if you don't have to, right? There's no reason to expand x minus 2 squared, so just write it as x minus 2 squared equals y minus 4. And the last step would be to move that 4 over. All right, so we have x minus 2 squared plus 4. All right, now I'm going to say this is a function. I know what type of function this is. It is a quadratic function. So I'm going to write down step 4, which is f to the negative first power of x, right? So saying this is the inverse function of f of x is x minus 2 squared plus 4. But let me show you what happens when I graph this entire thing and my original function 2 plus the square root of x minus 4. This will be a good conversation and a good reminder that you can't just move forward without thinking first with what's going on. So 2 plus the square root of x minus 4. Let's plot that first. 2 plus x minus 4. So there it is. All right, and then my inverse is x minus 2 squared. I already forgot. I think it's plus 4. Let's confirm. Yes. All right, you'll notice that when I plot y equals x as that, asymptote, it's not really there, but just that thought of like we're reflecting. You should notice as I zoom in that your original only has half of the parabola. So when you reflect that across that blue line, y equals x, I should only have half of a red parabola. So I should not have both pieces. So if you notice here, right, my starting point right here is 4, 2. Try again. There it is, 4, comma 2. So my starting point for my red point should be 2, comma 4. So what I'm going to do to restrict this, all right, is I'm going to write x values that are greater than or equal to 2. And now when I do that and restrict it, you'll notice that this makes sense in terms of, there it is, 2, 4. This makes sense in terms of what is being reflected. So I don't have too much in my inverse. So in terms of restricting my domain for my inverse, I need to write for my answer that x values can be 2 or more. So make sure that, especially, be on alert for this when you're looking at square roots or squares. That's usually when this comes up. So values for x that are greater than or equal to 2. So that's something that's tricky, and it's going to be something that will, get points taken off if you kind of forget that. Okay, let's talk about graphs, and then we'll be finished. So let's go ahead and graph f of x equals x squared, but they want us to restrict it on this domain. So I'm going to plug in positive values. So 0 squared is 0, 1 squared is 1, 2 squared is 4. So kind of similar to, or I guess an extension of what we just talked about. Here is half of my parent parabola function. All right, and it wants us to find the inverse and graph it on the same set of axes. So let's do the steps. So y equals x squared, step 1. Step 2, switch x and y. Right, that's the only thing you're switching. So x equals y squared. Step 3 is solve. So I'm going to take the square root of both sides. right? And when I do that, I need to put plus or minus in front if I do it. But if I were to graph the positive square root of x and the negative square root of x, that would be both pieces of the parabola on its side. So when I look at this, all right, and I'll just try to do it visually here and sketch this y equals x. Very similar to the discussion, if not exactly the same, to the discussion that we had on the previous problem. I should only have one piece of the parabola. So when I graph this, I should only have the positive version of the square root of x. Right? I should only have this piece of the parabola. Okay? If I were to include this piece down here, and I'm going to erase it, don't worry. But if I were to include that piece down here, that's too much, right? I only have half of the parabola in my original, so I can only have half the parabola in my inverse. And because of that restriction, when I go to step 4, I can actually put f to the negative first power of x equals just the positive square root of x. So just be aware there. If they had not done that restriction, right, restricted the domain, then we would not have a inverse function. We'd have an inverse, but that inverse would be a relation, right? So I'll show you real quick over here what I mean. Right, if I were to graph the original full parabola, right, not restricted, if I were to reflect that over that y equals x, it would look like this. And if you look at that parabola on its side, right, that fails the vertical line test. So that means it's not going to be a function. So just keep in mind that when you do this, you might have an inverse, but it may not be a function. All right, let's do one more. We'll be done. Let's graph x cubed minus 1. You can make a table if you want, or you can go to Desmos, or, I know that I just plug in values that are going to be simple, like 0, 1, and 2 to cube. So 0 cubed is 0, 0 minus 1 is negative 1. 1 cubed is 1, 1 minus 1 is 0. 2 cubed is 8, 8 minus 1 is 7. Negative 1 cubed is negative 1. Negative 1 minus 1 is negative 2. Negative 2 cubed is negative 8. Negative 8 minus 1 is negative 9. That's just a very fast way of making a table in my brain. I'll show you real quick on Desmos how you can make that exact same table and use Desmos to help you. So we have x cubed minus 1. So x cubed minus 1. If you hit this gear symbol and hit duplicate, and then make the second one into a table, you can type those in. Looks like they're already in there. Perfect. And you can type those in. Let's see if I move this for a second. There we go. Type those in. You can see all those points that I spoke about very quickly are all there. And that's exactly what I plotted right here. So I'll go ahead and connect that. For almost my parent cubic function, but we've shifted it 1 unit down. All right, so now find the inverse. So step 1 is to write y equals x cubed minus 1. Step 2, switch x and y. All right, step 3 is to solve for the new y. So I have x plus 1 equals y cubed. I'm going to be getting rid of that cube with the cube root. So I have the cube root, put that little 3 there in the index, cube root of both sides. And so I have y equals the cube root of x plus 1. So very similar to what I just did. I'm going to plug in numbers that I know that I can take the cube root of it after I add 1. So negative 9 plus 1 is negative 8. So negative 9 plus 1 is negative 8. Cube root of that is negative 2. Then I have negative 2 plus 1 will give me negative 1. Negative 1 plus 1 will be 0. 0, 1, and then 7 will give me 2. I'll show you in a moment how to do that in Desmos as well. All right, but you should not be surprised, hopefully, at how this looks. All right, again, if I were to sketch my y equals x here, there we go, and go the other way, you should see a reflection about this line for these two functions, right? And because I don't have any restrictions, or I don't have any issues with my domain, I can go ahead and write down step 4 that this is in fact a function. So I write f to the negative 1 of x equals the cube root of x plus 1. All right, let's go to Desmos and I'll show you how to finish this and hopefully put it together for your brain. So I'm typing in the cube root of x plus 1. So the cube root. So, oh man, I think there's something in here that'll help. Let me see. Make this go away. Make it smaller. I don't know. All right, let me see. I need to get this out of the way. All right, so I need to find the cube root function. There it is, the last one there with an n. So I type that in. Oh, I thought I typed that in. Oh, I put it up here. Oops. Let me go back. Sorry about that. Let's type it in the right spot. All right, so I have, there we go. Okay, so the cube root of, I think it's x plus 1. I'll confirm. It is. All right, let's move this out of the way now. I'm going to type in y equals x. And then I said I wanted to show you a table for this one. So let me duplicate this one and make it a table. And I think I use, what did I use? I used -9. Yes, -2, -1, 0, and 7. So there's all the numbers that I used. All right, let me get this out of the way. And if I zoom in a little bit, no, let's do that again. That's fine. You'll notice that the red one is my inverse. The green was the original. And so that you can actually see. Ooh, I don't know if I like that better or worse. Let's see what happens. Okay, so you can play around with which one you like. But anyway, they're both reflective about that line y equals x, which is blue. So anyway, that's the process for inverse functions. And don't forget to try some of the practice.